Okay, so we're going to look at how we use the vertex form to graph instead of the multiplied out version. So if we have this graph here and I ask you to graph it, we kind of got to think about what we figured out in that one activity where we were using our graphing calculators to play with these. If you don't remember and you've been having a hard time in class knowing like how this will shift things, what I'd like you to do is go to GeoGebra, and you're going to want to pause this video so you can write these down. Start with the graph of y equals x squared. Put that on your page, and then graph this one right here. Keep this one on your page, and look at this one and see what happened from this graph to this graph. Then go ahead and delete this one here or hide it, and then graph this graph and see, well, what happened from this graph to this graph. And go down this list and look at what's happening as I change different numbers here. Okay, as I add numbers in the parentheses, or as I add numbers or subtract numbers outside, as I do both of those things, as I multiply numbers, as I do all that, how does my graph change? This is my original graph, y equals x squared. How does it all change? How does the vertex change? All that kind of stuff. When you start to see the patterns, go ahead and write down what you see, because that is what we're basing off all of our stuff when we actually graph this. So once you've done that, you will have noticed on problems like this one, when I graph this original graph here started at there right on the origin, and this other one looks exactly like it, but it's 2 spots over to the left. Okay? If we go down here and we look at the same thing, we can kind of guess, well, that's probably going to follow the same pattern. So if it started here just at regular y equals x squared, if I have a plus 5, it's probably going to shift my graph over 5 spots. So I'm going to have a picture kind of like this. And then if you paid attention and you noticed what all these extra things outside did, well, this 25 actually ends up moving the parabola down 25 spots. So it's really going to look something like this. And I should actually be able to figure out what this vertex is. If it was 0, 0 here, and I moved it over to the left 5 spots, I'm now at negative 5, 0. And then if I moved it down 5 spots, this is now negative 5, negative 25. So without even doing anything, I just figured out the vertex. Well, the only problem is I kind of just sketched the rest of this, so I'm not exactly sure where these points are. So we do have to do a little bit of thinking on this one. Again, just like when we were doing the other form of the graph, what do we know about these points? Well, we know that the y value on these is going to be 0. So I do know that. So kind of if I was going to make a table again, I know that when x was negative 5, y was negative 25. This time I want to know where y is 0, and y is 0 at 2 spots. So just like if I put negative 5 into my equation, out comes negative 25. If I put 0 in for y, I should get a number out for x. So let's put 0 in for y here. So y could equal x plus 5 squared minus 25. Okay, and we can kind of think of this in a couple ways. We have to figure out what x is. Some people in class did something like this. So let me give myself a little bit more room. I'm going to rewrite this equation right here. So 0 equaled x plus 5 squared minus 25. Okay, we had some people in class say, well, I'm just going to add 25. I'm going to add 25. So 25 will equal x plus 5 squared. And if I want to find out what just x is, I could square root this. Well, what numbers when I square root them are 25? I get 5, so 5 would equal x plus 5. But also negative 5 is the square root of 25. So I actually have 2 equations. Negative 5 equals x plus 5. And why do I have to have 2 equations? Well, I have to have 2 x-intercepts, so I should probably have 2 equations to solve. This one here, if I subtract 5, x equals 0 at that spot. And that was when y was 0, x was 0. And if I use this equation, subtract 5, x is going to equal negative 10. So the other one when y was 0, x was equal to negative 10. And if I look on my graph, I should have a point at 0, 0, which I do, and I should have a point at negative 10, 0. Now I have all this graphed.